Hi guys, in this experiment we will see about load test on three-phase transformer connection. So the objective of this experiment is to find the generated voltage e.g. of a DC series generator for different field currents. Before we move to the circuit diagram, the precautions we should take care is that remove the fuse carriers before wiring and start wiring as per the circuit diagram. Fuse calculation. This is being a load test. The required fuse ratings are 120% of rated current. Keep the auto transformer in its minimum position at the time of starting. Replace the fuse carrier with appropriate fuse wires after the circuit connections are checked by the staff in charge. So the procedure will be keeping the auto transformer and load in its minimum position. The main supply is switched on by closing the TPSG switch. By slowly and carefully operating the auto transformer, the rated voltage 415 volt is applied to the primary side of the transformer. Under this no load condition, one set of readings, namely V2, I2, W2, V2 and W1 recorded in the tabular column. Now the load is increased in gradual steps and at each step primary voltage is maintained at no load voltage and then all meter readings are noted down. The procedure is continued until the current on the secondary side is equal to its full load value. After the experiment is completed, the load is decreased to its minimum. The auto transformer is brought back to its original position and then the main supply is switched off. For star to star connection, the primary winding terminals in star to star connections are A1, B1, C1 and A2, B2 and C2. The secondary winding terminals in star to star connection are A1, B1, C1 and A2, B2 and C2. Okay. To make star to star connection, A1, B1 and C1 are short circuited and given to the neutral. The terminals in A1, B1 and C1 are short circuited and given to the neutral. Now A2, B2 and C2 are given to the supply and here the A2, B2 and C2 are given to the load. This is star to star connection. For delta to delta connection, the primary terminal windings are A1, B1 and C1 and A2, B2, C2 for primary terminal windings. The secondary winding terminals are A1, B1, C1 and A2, B2 and C2. For delta connection in primary terminals, the A2, B1 and B2, C1 are short circuited like this one. And then the supply is given through A2, B2 and C2. For delta connection in secondary, the terminals A2, B1 and B2, C1 and C2, A1 are short circuited and the load is connected through A2, B2 and C2. And delta to delta connection, for delta to star and delta to star connection, the connection will be given like this one. The procedure for connecting delta to star connection, the document is given in the description below. So I have taken the values only for star to star connection. So the tabular column will look like this one. Here input, output, and efficiency, and finally the regulation and input current. So the input will be voltage, current, and wattmeter. Here the wattmeter multiplying factor is 8. And then for output, voltage, current, and wattmeter reading, and efficiency, and finally the regulation value. So the formula used will be efficiency is equal to output power by input power into 100, and the percentage regulation will be VHV at no load and minus VHV at full load by VHV at no load into 100. So the model graph will look like this one. In y-axis percentage efficiency and percentage regulation, and in x-axis value will be output in watts. So I will give a model calculation for few values. So the percentage regulation is equal to V no load minus V load by V no load into 100. So first value is equal to V1 is equal to 4115 minus 415 by 415 into 100. So value will be 0. The percentage regulation will be 0. Now for second value, V1 is equal V1 is equal to 412, V2 is equal to 384. So I have taken V no load as 415. So V2 is equal to 415 minus V load is equal to 384. 384 by 415 into 100 is equal to 7.5. The percentage regulation will be 7.5. Like this you can do for all the values with V no load as 415 volt, because in the procedure we have mentioned that by slowly and carefully operating the auto transformer, the rated voltage 415 volt is applied to the primary side of the transformer. You can see the 415 volt. So the no load will be 415. So with this tabular column we will draw a graph. So the graph will look like this one, with the corresponding y1 y2 axis with percentage efficiency and percentage regulation, and x-axis will be output power in watts. With this graph the experiment is over. Thank you.